Imagine a structure so massive it makes a Boeing 740. 7 look like a toy. Now, imagine that same giant, a 12-story building made of fabric and hope, completely ceasing to exist in exactly 34 seconds. You're probably thinking, okay, it was big, but was it Titanic big? Actually, yes, literally. The Hindenburg was 804 feet long, 245 meters. That is a pathetic 28 yards, 25 meters shorter than the Titanic. It was a flying ocean liner, but here's the kicker. While the Titanic took nearly 3 hours to sink, the Pride of the Reach took less than a minute to turn into a skeletal graveyard. But surely you might say it's a giant balloon filled with hydrogen. Of course it exploded. Well, strictly speaking, it didn't even explode. It just burned with terrifying efficiency. And before you start lecturing me in the comments about Nazi engineering, remember, this ship had flown across the Atlantic 34 times without a single scratch. It was considered the safest way to travel. Until, suddenly, it wasted. Enter Herb Morrison. You know his voice, even if you don't know his name. Oh, the humanity. But did you know we only have that recording because Morrison was using an experimental Presto Direct to disc recorder. Radio waste usually recorded live back then. It was too expensive. This was a tech trial, and boy, did they get more data than they bargained for. His voice actually speeds up on the record because the shock of the blast physically jarred the equipment. Talk about a vibe check. Now, look at this fireball. Looking at these newsreels, you'd bet your life savings that nobody walked away from that right. Wait for it. Wrong out of the 90. 7 people on board, 60. 2 survived. Yes, you heard that right. You had a roughly 60 for a chance of surviving a fall from a burning hydrogen palace. How? Well, that is a rabbit hole that involves acrobatic rolls, bursting water tanks, and some very fast sprinting. But we aren't here just to watch things burn. We're here to find out why a ship designed to be the pinnacle of human achievement became the ultimate formula for disaster. And to understand that, we need to look past the flames and inside the belly of the beast, because the real mystery didn't start in New Jersey. It started years earlier with a pile of beef intestines and a global monopoly on a gas that refused to stay put. Before we get back to the burning to a crisp part, we need to talk about why anyone would spend their life savings to board this thing. To the public in 1936, the Hindenburg waste to bomb it was a miracle. It was the ultimate flex of German engineering. Imagine a library so quiet you could hear the wind whistling past the canvas because the massive tank engines were suspended so far away from you on struts. Now, let's talk about the most metal and yet least metallic part of the ship, the gas cells. You might think, oh, they probably used high-tech synthetic polymers. Wrong. They used gold beater's skin, which is a fancy term for purified beef intestines. 762 cubic of hydrogen. To hold all that gas, the Germans needed the guts of more than 700,000 cattle. Ill wait while you process that. Every time the Hindenburg flew, it was lifted by the collective sacrifice of a medium-sized city's worth of cows. I see you in the comments. No, they didn't smell like a slaughterhouse, mostly. Weight was the Hindenburg's greatest enemy. Every gram was a battle. That's why the furniture was made of bent aluminum to be like your modern office chair, but more chic. But the wealthy elite wanted culture, so the Buthner Company built a special grand piano made entirely of Duralumin. This thing weighed only 397 pounds, 180 kg, compared to a standard Grand that weighs over 1,000. And for the final touch of why, though, they covered the whole Duralumin piano in yellow pigskin. Nothing says class like playing Mozart on a lightweight metal instrument wrapped in a farm animal. But here is where the Hindenburg's engineers really decided to tempt fate. They built a smoking room. Yes, on a ship filled with 7 million cubic feet of hydrogen. But is that suicidal, you ask? Well, they engineered their way out of the boom. The room was permanently pressurized to ensure that air only leaked out, meaning no hydrogen could ever sneak in. You entered through an actual airlock, and a bar steward watched you like a hawk. You weren't allowed matches or lighters. Hose were confiscated at the door. Instead, there was one single electric lighter bolted to the wall. One spark in one room, protected by physics. It was perfectly safe until the physics of the outside of the ship decided to stop cooperating. You're starting to see the pattern, right? They thought they had accounted for everything. The cows, the pigs, the pressure. They thought they had built a fortress of luxury that science couldn't touch. But as we're about to see, all the pressurized smoking rooms in the world don't matter when you realize your entire multi-million-dollar bridge across the ocean is held together by political pride in a gas that wanted to be anywhere but inside those beef guts. Let's talk about the Scheissfahrt. Now, I know what you're screaming at your screen right now. If hydrogen is basically a liquid bomb with a death wish, why on earth were they using it in the first place? It's a fair question. It's like building a skyscraper out of matchsticks and being surprised when someone lights a candle. But here's the thing, the Hindenburg wasn't actually designed to be a flying torch. It was designed for helium. Into the United States, in the 1930s, the US had a literal global monopoly on helium, and thanks to the Helium Control Act of 1927, they weren't sharing. The US military looked at Nazi Germany and said, yeah, giving you the non-flammable gas that makes your giant scouting platforms invincible. That's a no from us, dog. Therefore, the Germans had to re-engineer the entire ship for hydrogen. Ironically, because hydrogen is lighter, it gave them more lift, which mean-to-you guessed Ithy could cram in more luxury cabins. Classic engineering. It might explode, but at least we have more room for the Duralumin piano. This brings us to Hugo Eckener. He was the Pope of airships, and he absolutely detested the Nazis. He saw them as thugs who were ruining his life's work. But Goebbels, the propaganda minister, saw the Hindenburg as the ultimate flying billboard. In March 1936, Goebbels demanded the ship go on a propaganda tour over the Rhineland before its endurance tests were even finished. Eckener was livid. He refused to fly it, so Captain Ernst Lehmann, who was much more amenable to the regime, took the wheel. On takeoff, a 35-degree crosswind gust slammed the ship's tail into the ground, ripping the fabric and damaging the rudder. When Eckener heard about it, he didn't just give a stern talking to. He screamed at Lehmann in front of everyone, calling the whole Nazi propaganda stunt a Scheissfahrt, which, for my non-German speakers, translates roughly to a shit flight. Imagine calling the Führer's personal project a shit flight to his face. Eckener had balls of Duralumin. Goebbels was so howling mad that he effectively banned Eckener's name from being mentioned in the press. But the Nazis got their billboard anyway. The Hindenburg was a monster of a machine. It had 15-meter 50-foot swastikas painted on its tail fin so large that people in New Jersey complained they could see them from miles away. During the 1936 Berlin Olympics, it flew so low over the stadium that it literally blocked out the sun for 3 million spectators, all while towing a massive Olympic flag. It was a symbol of German resurgence, intended to prove supremacy in all fields from sport to aviation. It was a masterpiece of technology being used to sell a nightmare. Wait, you might ask, is this a history lesson or a political drama? Well, in the case of the Hindenburg, they are the same thing. Because of that embargo, they were flying with 7 million cubic feet of beef, gut, contained hydrogen. And because of that Nazi pride, they were obsessed with a 100 punctuality record. They wanted to show the world that German engineering didn't care about little things like Atlantic storm. But as we're about to see, when you're 12 hours late and your tail is dragging, pride is the first thing that burns. Let's look at the fatal maneuvers of Captain Max Pruss. So, we've got our flying palace made of cow guts, fueled by political ego and a gas that's just looking for a reason to go home. Now, let's add the final ingredient to our formula for disaster, stress. It's May 6th, 1937, and the Hindenburg is failing at the one thing German engineering is supposed to be famous for: punctuality. Because of a series of brutal Atlantic storms and massive headwinds, the ship is 12 hours behind schedule. Imagine your flight being 12 hours late, but instead of a terminal floor, you're stuck in a 135-foot wide balloon. You might think, big deal, it's a luxury cruise, just enjoy the extra caviar. But Captain Max Pruss didn't have that luxury. He was under massive pressure from his higher-up, Ernst Lehmann, who was basically the ultimate backseat driver. Why the rush? Because on the ground at Lakehurst, there were 70 passengers already waiting to board the return flight. And these weren't just random tourists, they were high society types heading to London for the coronation of King George V. If Pruss didn't land now, the rich pride would cause an international nightmare by making the elite miss the crowning of a king. Wait, I see you typing already. Didn't they fly into a massive thunderstorm? Actually, no. By the time they reached Lakehurst, the main storm front had already passed. The weather was clearing, but as Hugo Eckener later pointed out, there was a smaller, sneakier storm cell lurking right behind the main one. Pruss saw a tiny window of opportunity and decided to go for it. He didn't just approach the mast, he rushed it. And that is where the physics of floating scales started to break down. As the ship made its final approach, something was wrong. The Hindenburg was stern, heavy, in plain English, its butt was dragging. Pruss and his officers are frantically trying to level the ship. First, they release water ballast. Not just a bucket-filthy dump one kig, two elbs of water from the tail section in 3 successive drops. Did it work? Nope. The ship was still tilting. So, in a move that sounds like a comedy sketch but was terrifyingly real, they ordered 6 crew members to sprint to the very tip of the bow. They were using human beings as living weights to keep the nose down. Think about that, a 12-story-tall ship being kept level by 6 guys running through a dark corridor like their lives depended on it. Which, spoiler alert, they did. At 7 p.m., the wind suddenly shifts to the southwest. Pruss is now close to the mast and doesn't have room for a wide, gentle turn. Instead of aborting and trying again, he executes a sharp, high-speed stern. Now, imagine a structure longer than 3 Boeing 747s twisting like a pretzel at full speed. This maneuver put extreme tension on the Duralumin frame, specifically the shear wires holding the tail together. Eckener later concluded that one of these bracing wires, which were later found to be substandard, snapping at only 70 of their rated load likely, snapped and slashed right through a gas cell. This is the moment the invisible disaster, the wire snaps, the cell is gashed, and hydrogen starts pouring into the space between the gas bags and the outer fabric. On the ground, witnesses see a peculiar flutter in the fabric near the tail fin. It looked like a waving sail. It wasted the wind, it was the gas escaping. Now you have a huge pocket of pure hydrogen mixing with the outside air, just waiting for a spark. You've got the fuel, you've got the oxygen. All you need now is a single electron to jump the gap. So we have a leak, but a leak without a spark is just a very expensive way to make New Jersey smell like. Well, nothing, because hydrogen is odorless. You're probably staring at your screen thinking, okay, scientist, where did the fire come from if there were no matches allowed? The answer is that the Hindenburg didn't need a match. It had become a giant flying capacitor. While flying through those stormy conditions, the airship's movement through the highly charged atmosphere caused its outer skin to build up a massive static chargeathos, ends of volts. But wait, you might object, is the whole thing made of metal? Shouldn't the charge just bleed off? That is where German engineering accidentally designed a death trap. The outer cotton skin was actually isolated from the metal frame by non-conductive Ramey cords. These cords were lightly covered in metal to improve conductivity, but they weren't effective enough to equalize the voltage. Therefore, as the ship drifted through the storm, the skin held its charge while the frame stayed at a different potential. The dope painted on the skin cellulose acetate butyretected like a capacitor's dielectric, allowing the skin to store even more energy than a simple balloon. It was a 12-story battery waiting for a circuit to close. At 7:21 p.m. they dropped the landing ropes. These were made of manila hemp. Now, you'd think a rope is an insulator, but in the light rain of Lakehurst, they became conductive enough to act as a ground wire. The second those wet ropes touched the earth, the Duralumin frame of the Hindenburg was instantly grounded. And here is the but that whilst the outer skin remained isolated and highly charged. This created a massive potential difference between the grounded frame and the charged skin. It was a formula for an arc. All it took was one of those frames near the hydrogen leak to be close enough to the skin for a spark to jump the gap. I know what you're thinking. If it grounded at 7:21, why did it wait until 7:25 to burn? That 4-minute delay is one of history's greatest gotchas. Science tells us that rain was the necessary component for the disaster. The landing ropes were dry when they first dropped, so grounding wasted perfect initially. It took time for the rain to soak into the ropes and the fabric skin, slowly increasing their conductivity until the voltage difference finally reached a breaking point. Imagine a cup slowly filling with water. It doesn't overflow the second you start pouring, but the mess is inevitable. Don't believe me? Ask Professor Mark Heald of Princeton. He was standing near the main gate with his wife and son, watching the landing through the darkening sky, while other witnesses were blinded by the setting sun on the port side. Heald had a clear view of the starboard background. He reported seeing a dim blue flame in the sea, Elmer's fire or a brushed stroke, flickering along the top ridge of the ship a full minute before the fire erupted. He even turned to his wife and said, "Oh, heavens, the thing is afire." He wasn't seeing combustion yet. He was seeing the physics of the atmosphere, trying to rip the ship apart. Before the hydrogen even knew what was happening. There you have it. A sharp turn, a snapped wire, a leaking cell, and a wet room. Physics does care about your coronation schedule or your Nazi propaganda. Just follows the path of least resistance. Before you go away thinking this is an open shut case, we need to address the rocket fuel. Because in the 90s, someone decided the gas was they claimed it was the paint. And that, my friends, is a whole other level of crazy we need to do. Let's look at the myths. You can already see the comment section bubbling over with Addison Bill. In the 90s, this retired scientist dropped the bombshell theory that's been floating around the internet like a stubborn gas pocket ever since. He claimed the hydrogen waste was the problem with paint was. He basically argued that the Hindenburg was coated in solid rocket fuel. It sounds cool, right? A giant Nazi rocket disguised as a balloon. But let's look at the actual chemistry. The dope used to seal the fabric did contain iron oxide and aluminum powder, basic ingredients of thermite. Bute, and this is a big butot, or 1014 for thermite to actually work as an incendiary. You need a very specific 3:1 ratio of iron oxide to aluminum. The Hindenburg skin had the exact opposite. Way too much aluminum and nowhere near enough iron oxide. It's like trying to bake a cake with 3 gallons of salt and a pinch of flour. It just is going to rise. Surely it was still flammable, you ask. Sure, it could burn. Everything burns if you try hard enough, but science follows a speed limit. Modern tests on replica fabric show that even if you coated the ship in actual rocket fuel, it would have taken roughly 12 hours to burn from tail to wing. If you used the Hindenburg's actual paint formula, the ship would have smoldered for 40 hours. Now, look at the newsreels again. The Hindenburg was gone in 34 seconds. That's the propagation speed of over 9 meters per second, roughly 20 feet. Paint moves at 1 meter per second. Hydrogen, however, is a speed demon. It moves at exactly the velocity we see in the footage. Therefore, the paint might have added some sparkle to the fire, but hydrogen was the one driving the bus. If it wasn't the paint, maybe it was a person. Enter the most Hollywood suspect in history, Joseph S., a professional vaudeville acrobat known by the stage name Ben Devil. The Gestapo and the FBI both had him at the top of their list. Why? Because he had a Dogo German shepherd named Alekinald in the freight room near the tail. He's made several unaccompanied trips during the flight to feed his dog biscuits. To a nervous crew, the guy who moves like a cat, sneaking around the hydrogen cells screams saboteur. But this wasn't a spy. He was just a guy who really loved his dog. And he survived the crash in the most badass way possible. He smashed the promenade window with his camera, climbed out as the ship fell, and when he was about 6 meters, 20 feet above the ground, he did a literal Parker roll into the sand. He walked away with nothing but a broken ankle and a very confused story for the FBI, who eventually found 0 evidence against him. So, the ship is gone, the passengers are buried, and the theories are busted. But there is one final dark detail they didn't teach you in school. What happened to the wreckage? The massive, charred skeleton of the world's greatest flying menace was scavenged and shipped right back to Germany. There, the symbol of German peaceful engineering was melted down. The Duralumin from the Hindenburg was recycled into military aircraft for the Luftwaffe. The very metal that carried socialites to New York was turned into the engines and wings that that would drop bombs on London just 3 years later. Talk about a recycling program from hell. Hugo Ekener's dream of a bridge of friendship across the Atlantic didn't just burn, it was weaponized. Wait, you might say, couldn't they have just used helium and saved the industry? Maybe, but the truth is, the Hindenburg was a dinosaur before the fire even started. While it was floating gracefully at 80 miles per hour, the Pan Am China Clipper was already crossing oceans much faster. The airship offered comfort, yes, it had the pressurized smoking rooms, and the cow gut contained luxury. But the world was moving into an age where people valued time over caviar. The disaster didn't just kill 36 people, it killed the public's patience for floating scales. So, next time you're stuck in a tiny airplane seat with a bag of pretzels, remember the Hindenburg. Remember the 700 cows that gave their lives for its gas cells. Remember the pigskin piano and the pressurized airlocks. We traded the flying palaces for safety and speed. It was a fair trade, probably, but we lost the poetry of the sky along with the hydrogen. The formula for disaster was simple: static electricity plus human pride. Physics always wins in the end, and physics, as it turns out, has a very dry sense of humor. Did you know about the Luftwaffe recycling, or S. Parker move? Let me know in the comments if you think the age of airships should make a comeback with helium this time, obviously. Don't forget to like and subscribe for more deep dives into history's most expensive mistakes. See you in the next one.